This is the CV1. It has only one analog output and 3 gates. That's the plan. That's the microcontroller. That's the microcontroller board, the motherboard. This is one of these encoders with a switch with push buttons built in, and one of these 3 Euro LCDs, where we have 2, and there are also 4 LEDs, 4 jacks, 1 switch, and a handmade case of steel. Yeah. It has 4 pages, virtual encoder pages, like you know it from MIDI controllers. And this is not only a MIDI controller, it's just a MIDI box CV mixed with sequencer and motion sequencer stuff, I call it. So we have 3 pages. The only page that is ready now is the motion sequencer page. It's really pretty, and some kind of LFO. The first page should be envelope, a classical envelope triggered from MIDI inputs, node input data, classic RSR plus minus offset. The second page will be LFO with rate, which is tempo synced, like you see it, running very slow. Here's the point. To really fast. So it's a combination of a trigger, which is really fast from a sequencer, and the slow and or fast but steady envelope LFO curve, and the third thing, the human touch, the motion sequencer and the sequencer itself, that's synchronizing all together. These are the 3 pages. Now let's focus on this motion sequencer and sequencer side, because this is already ready. These push buttons are described by the LCD on the top, and the rotary things are described on the bottom. For example, run sequencer. When we press this, a status bar now show us the progress. It's very slow because we have only 14 ppm. The ppm encoder makes it faster, of course. This points from left to the right, 32 steps long, 32 resolution. It's very fast. It's only a sync track that is synchronizing the tempo changes in the background, for example, when I change the rate of the LFO, so that it will keep in sync. So, and this power for the motion sequencer, it's paused. Now it's running. You see this progression bar on the top. It's a bit slower, and we can change the lane with the page encoder. Now it's very slow, up to 512 ppm steps on different time structures like 3/4 takt system. Now we go to 4/4. 64 steps per page multiplied. A page has 64 multiplied by 8. You can come to 512 steps. So the sequencer is now running very slow, and when we press the record button, you see this crosses, these arrows, and this encoder has a special feature. It shows you draw envelopes, fast or not fast. You have a 32 resolution and a 16-bit resolution integer from 0, 1 to 65,000. So it's very precise. And when I press this again, it will be looped what I've done here. And we can make this shorter from 512 steps back to 64 steps. So we have a fast moving envelope made by hand. So we have a custom waveform now that is changing the CV. We have only one CV, which is digital mixed together. And this is offset. This is the plan. When we combine now the fast LFO, which we have on the second page, where we can change the rate, which is very slow when we see this point, but it's on an exact curve function, which is always the same. You can trust on this. Only make it real fast, so fast that it's impossible to make this with a motion sequencer on this side precise. So we mixed these functions together, and with the plus minus offset we mix it together to envelopes that are cool. On the first track, like I said, there should be an envelope, a classic envelope. Yeah. On the motion sequencer side, we can clear all. We can clear this motion sequence now, and it's free to make other things with this. Or we pause this, also possible. Yeah, that's for the first impressions for this thing. Good night.